The gambler's fallacy. 4 bets have lost in a row. The 5th one feels overdue. The standard correction is that the 5th bet has no idea the other 4 happened. That correction is right, and it's incomplete in a way that matters. Something in the arithmetic of finite sequences keeps handing the fallacy evidence, and until 2018, nobody had worked out what it was. Next, what the fallacy claims. The fallacy makes one claim. A run in one direction makes the opposite outcome more likely next time. Amos Tversky and Daniel Kahneman traced that to the representativeness heuristic in Science in 1974, which is the habit of expecting a short stretch of results to look like the population it came from. 3 years earlier, in Psychological Bulletin, the two of them had given the underlying tendency its name: belief in the law of small numbers. 5 heads doesn't look like a fair coin, so tails feels owed. A coin has no memory and no ledger. Its next flip is 50-50 the way every flip before it was. The same holds for a point spread. It's set for one game against one opponent on one afternoon. 6 heads running is unlikely at the outset, at 1.56%. After 5 heads have already landed, though, that number has stopped being the question. The 5 are settled. Only the 6th is uncertain, so the odds on it are the odds on any flip. Next, 26 blacks in a row. The other name for the fallacy comes from a roulette table at the Monte Carlo Casino. On the 18th of August, 1913, the ball fell in black 26 consecutive times. On a single zero wheel, a run that long in either color comes to about 1 in 68 million. The story goes that gamblers lost millions of francs backing red, betting heavier each spin on the conviction that black had to break. Whether the losses ran to millions is the part nobody has ever documented. It doesn't need to be true for the anecdote to earn its name. Every spin after the first was priced identically to the first. Next, money that moves on the fallacy. Charles Clotfelter and Philip Cook put a figure on the behavior using Maryland's daily numbers game, publishing in Management Science in 1993. The amount wagered on a given number falls sharply straight after that number is drawn, then climbs back to its old level across the following months. Nobody in that data is confused about the mechanism. A daily numbers game is transparently random, and the players know it. They avoid the recent winner anyway. Which game it is decides who pays for the belief. The Maryland game pays fixed odds, so avoiding the recent winner there costs a player nothing against any other number. Plenty of lottery games are parimutuel, though, splitting a pool among whoever picked correctly. In a parimutuel pool, a number everybody has decided is exhausted pays more when it lands, because fewer tickets share the pot. So in those games, the fallacy costs the people holding it and quietly funds anyone who ignores it. Next, why experience keeps confirming it. Joshua Miller and Adam Sanjurjo found the mechanism and published it in Econometrica in 2018. The experiment runs like this. A fair coin gets flipped 3 times, and every flip that came immediately after a heads is written down. Averaged over every sequence that produces such a record, the proportion of heads in it settles at 5/12. 41.7%, against a coin that is honestly 50-50 throughout. The site ran the 8 possible sequences to check. The fraction is exact. At 4 flips, the recorded proportion drops further, to 17/42, about 40.5%, which is the deepest the bias goes. Conditioning instead on a run of 3 heads inside 10 flips brings the recorded figure down to roughly 35%. Miller and Sanjurjo call this streak selection bias. It exists because choosing which flips to examine on the basis of what preceded them is not a neutral act in a finite record. The magnitude generally shrinks as sequences lengthen, and it grows as the streak being conditioned on gets longer. So the reversal intuition is wrong about the next flip in isolation, and right about what turns up when somebody goes back through a finite record and counts. Those two things being true at once is why the belief survives contact with experience. A bettor watching their own results is looking at exactly the kind of short, self-selected record where reversals really do show up more than half the time. Next, what that did to the hot hand. The mirror image error is the hot hand, the belief that a run will continue. Thomas Gilovich, Robert Vallone, and Amos Tversky examined it in basketball shooting in Cognitive Psychology in 1985. Fans and players believed in it firmly. Shooting percentages, the authors reported, looked independent of previous makes and misses. For 3 decades, that stood as the definitive result. Miller and Sanjurjo showed the canonical study used the same biased selection procedure their coin example exposes. Corrected for the bias, its long-standing conclusions reverse. The hot hand in basketball shooting now has evidence behind it, and the paper that spent 30 years disproving it was measuring the artifact. None of which converts into a betting position. A shooting hand is one player under repeatable conditions. A team covering 5 straight spreads is a different object, priced fresh each week by people who watched the same 5 games. Next, what a covering streak is worth. Team streaks are where this lands for anyone reading a betting board. 7 straight covers looks like a debt coming due. A run that long inside a single 7-game window has a probability of 0.78% if the team is a coin flip against the number. Widening the window breaks the impression. Across a full 17-game season, a coin flip team strings 7 covers together somewhere in there 4.67% of the time. Spread over 32 teams, that's roughly 1.5 of them every year, purely from chance. Runs of 5 turn up in about 7 teams a season on the same assumption. So a covering streak is close to guaranteed to exist somewhere on the board, and the team holding it is the one everybody notices. Whether that team is genuinely mispriced or merely the one the coin favored this year is a question the street can't answer. Next, regression is a different claim. Regression to the mean gets folded into the fallacy constantly, and it's a separate and genuinely true thing. A team that starts 14-2 probably won't repeat it, and a hitter batting 400 in April probably finishes nearer 280. Extreme results carry luck, and luck doesn't repeat, so later performance sits closer to the underlying ability. Ability held steady the whole time. What improved was the measurement of it. The 2 claims are worth keeping apart. The gambler's fallacy says the next flip is likelier to be tails. Regression says a 400 average was partly noise, and the noise won't recur. One of those is false and the other is true, and the true one is already inside the price by the time a line goes up. Next, why none of it helps at the window. A bettor winning 55% of the time, which would be an exceptional rate, hits 6 consecutive losses about once in every 120 stretches of 6 bets. Across 300 bets, the chance of running into at least one such stretch somewhere is 75.2%. 3 seasons in 4 contain 1. It's the ordinary texture of a winning record. What the fallacy does with a stretch like that is turn it into a reason to bet bigger. The recovery plan doubles the stake after every loss. At -110, the 6th bet in that sequence is 42.79 units, and the running total staked is 80.68. By the 10th loss, 1,588 units are gone, and the bet that would recover them sits at 1,747. Since 3/4 of seasons contain a 6-loss run, the plan that requires the run to stop is the plan most likely to meet one. Flat stakes remove the mechanism entirely. The deeper reason none of it helps is that a bettor can't wager on the selection. Miller and Sanjurjo's bias appears when somebody sifts a record after the fact, choosing which entries to count. A sportsbook offers one game at one number, chosen by the book rather than by the bettor, and the number carries no memory of Sunday. Streaks are real, the pattern in the record is real, and neither is available to buy. 4 losses in a row will keep feeling like something. The arithmetic behind that feeling is now published, and it still won't pay for the 5th bet. If this was useful, hit the like button and subscribe. The full analysis, with sources, is at LoserWins.com.